Welcome to another lesson on naming ionic compounds. In this lesson, we're going to look specifically at ionic compounds that contain polyatomic ions. So, up until now, we've learned how to name ionic compounds that contain metals and nonmetals. And we see the nonmetals and the metals when we look at our periodic table. We can find their names, we can find their symbols, and we can find their charges. Those types of ionic compounds that contain two ions are called binary compounds, meaning that you have two components in the compound. Now we're going to look at some ionic compounds that, when we look at their formulas, have more than one element present, or more than two elements present in the formula. So polyatomic ions are not going to be found on your periodic table. Polyatomic ions are essentially clusters of elements that have an overall charge. So in other words, a polyatomic ion is several atoms bonded together covalently, such as sulfur with 3 oxygen atoms bonded to the sulfur covalently, but the whole compound has an overall charge of, in this case, -2, and this is a polyatomic ion. We can treat it just like one ion, okay, or like one unit, and it has a name. You are not responsible for knowing how to name these in Chemistry 11, but you are responsible for being able to recognize them and looking them up on the chart that you have that gives all their names. So in this case, SO3 2- is sulfite, and we could see that in a compound, and it would this SO3 2- is a polyatomic ion, and these guys can bond the same way that a simple ion can bond with another ion. So you do need to be familiar with this chart that you have in your data pages. It's called Names, Formula, and Charges of Some Common Ions. And there's a couple of things that I'm going to point out to you on this chart. First of all the polyatomic ions that you need to know in Chemistry 11 are listed here. However, being able to find them quickly is going to be helped if you highlight them right on your chart or put a little star beside them to indicate which ones are polyatomic. You'll notice that this chart doesn't just list polyatomic ions, it lists almost all the common ions and their charges, which means that you also have some simple ions on here too. So if you were to take your highlighter and just highlight the polyatomic ions, it might help you when you're looking up the names of a polyatomic ion. So a couple things I want to point out. First of all, on the left-hand side of this chart, you have positive ions, cations. So as we know, metals from our periodic table form cations when they lose electrons. The other cation that you could possibly have is the polyatomic ion ammonium. If I highlight ammonium on my chart here, that'll be really helpful for me as I'm trying to find the name of NH4 or look up the formula for ammonium later when I'm dealing with polyatomic ions. Notice that ammonium is the only polyatomic ion that is a cation, or that has a positive charge. So there are no other cations that are polyatomic other than ammonium. That's really helpful to know. So in other words, when you're looking at a formula, for it to be for that compound to contain a polyatomic ion, it would have to start with NH4+. Yeah, if the cation was positive. Okay, that on the other side of this chart, we have all of the anions, or the negative ions, and there are many polyatomic ions listed here, but it is really helpful to go ahead and highlight them. And you'll notice that, so any of these compounds that contain more than one element are polyatomic. So carbonate is one, chlorate. Chloride is not one, because Cl- is just simply chlorine that has gained an electron to form the chloride ion. But chlorite is there, chromate, cyanide, dichromate, hydrogen phosphate, and so on and so on. You could go ahead and highlight these. I'm going to do it really quickly. Okay, but essentially it's anything here that has more than one element present. Hydroxide is a really common one. Monohydrogen phosphate, nitrate and nitrite, oxalate, perchlorate, and finally sulfite and thiocyanate at the bottom. A couple of things to point out on here. Seeing as we have the chance to talk about it in the lesson, there are several polyatomic anions that have very similar names, and you need to be a bit careful with them. One of them is sulfate. Whoops. Notice that the ending on sulfate is very similar to sulfite, but these are two different polyatomic ions. There's a different number of oxygens. Another one that is commonly aired, or students often mix them up, is nitrate and nitrite. Again, different number of oxygen atoms bonded to the nitrogen here. So just be a little bit careful with those. Some of them you'll notice have two names, and it is correct to use either of the names that are listed when you're naming these. Hebden tends to use the first name here, okay, that's listed, but you will also very often see bicarbonate, for example, used instead of hydrogen carbonate. So either one of those is totally acceptable and correct. All right, let's go ahead and do some examples of these now. So we're going to start with naming, and I have here a compound NaClO2, and the first step in recognizing that you have a polyatomic ion is to see that this is not a simple binary ionic compound. In other words, I don't just see two elements in this compound. So by comparison, if I was looking at NaCl, there's one element, there's another element. I have two ions present here, so I know that I'm going to find these on my periodic table. There's no polyatomic ions present here. The moment we see more than one element symbol here, so I've got sodium, I've got chloride, and I've got oxygen, I know I have a polyatomic ion here. The trick is recognizing which part of this compound, the way it's written, is my polyatomic ion. Okay, it's recognizing where is that. Part of that will come as you get familiar with the polyatomic ions and their formulas. But you could start by looking up on the cation side, is there a polyatomic ion that has Na in it? NaCl, is that a polyatomic ion? Well, no, it's not. You're not going to find it there. All you'll find is sodium, Na. So sodium is obviously the metal ion, sodium. That means that the second part of this compound, ClO2, is my polyatomic ion. So I need to look this up on my ion chart and figure out what its name is. I already know the name of sodium, Na. Okay, so I could go ahead and write that out. And I've simply found that by going to my periodic table and looking up Na, sodium. Okay, and the polyatomic ion, ClO2, can be found right here on my chart, and the name of it is chlorite. The best part about naming ionic compounds that have polyatomic ions is that you do not change the ending. If you recall before, when we were naming ionic compounds that were simple binary ionic compounds that have a nonmetal present, we always change the ending of the nonmetal to IDE. You do not do that with polyatomic ions. You always leave the name of the polyatomic ion the same as you see it in the chart. So I do not change this. Notice that if I did change this to IDE, all of a sudden I would be talking about a different compound. If this was sodium chloride, well, that would be the formula for that compound. So definitely not correct. So you do not change the endings of polyatomic ions. You leave them exactly as they're written in the chart. So that's pretty easy. Sodium chlorite is the name of this one. Let's do a more difficult example. Here's one that looks a little bit daunting to look at it. NH4 in brackets 2Cr2O7. Okay. Again, the first trick here is recognizing that you have a polyatomic ion, and I can see the fact that I have more than one element present here. There must be a polyatomic ion in here. The next step is just breaking it into its respective ions. So I noticed that the NH4 is in brackets. There's a hint. Okay, NH4 is one of our polyatomic ions. So, and there's two of them in this formula. So the first thing I want to do is look up NH4 on my chart. And I know it's going to be on the left-hand side with the positive ions because it comes first in the formula, which means it's a cation, a positive ion. And remember what I told you before, there's only one positive polyatomic ion, and that is ammonium. So there it is, NH4, and its name is ammonium. And so I can name it. And I don't change the name at all. Okay, the next polyatomic ion that I need to look up then is this second cluster of elements, Cr2O7, and I'm looking that up on my chart, not on my periodic table. Cr2O7, and there it is right there, and its name is dichromate. And I'm done. Kind of a scary looking compound, pretty simple name to figure out. So ammonium dichromate. Let's do another one. MgSO4. As you're getting more and more used to naming ionic compounds, you might start to recognize the symbols for metals really quickly, and you might say, hey, Mg, I know that one, that's magnesium. Okay, or you might look it up on your periodic table. You know you have a polyatomic ion here because you have three element symbols. You have Mg, S, and O. So this is not a binary ionic compound. You have a polyatomic ion somewhere in here, and it's going to have to be the SO4 because, as we said before, the only polyatomic cation that you can have is NH4 plus, and that's clearly not what we have here. So we know we're talking about magnesium as the metal and SO4 as the anion, the polyatomic anion. So again, you look up magnesium on your periodic table, and remember, we're always checking when we look at metals to make sure that we don't have a multivalent metal, and in this case magnesium has only one possible charge, it's 2+, and so I don't have to worry about putting Roman numerals in my name for the metal. So magnesium is the name of this one here, of my metal, magnesium, and then I name my polyatomic ion exactly how I see it in my chart, and I need to look it up, SO4. These are alphabetized, so you go right down to the bottom. SO4 is right here. Sulfate, not to be confused with sulfite, which is SO3. So SO4 is sulfate, and I write it just as I see it. Perfect. Done. So naming, not too hard when we have polyatomic ions. The trick is just recognizing that you have them and then looking them up on your chart. I see a lot of students trying to name this magnesium sulfur oxide, and that would be incorrect. We are not expected to know how to name the polyatomic ions, so please don't try. Do have your chart handy and highlight it if that helps you, and do get used to using your chart to look up those polyatomic ions. Let's now write the formula of some ions given their names. A little bit of a trick here, or a helpful hint, is that if you've spent more than 3 minutes looking up the name of an element on your periodic table, go to the polyatomic ion chart, or the chart of common ions. So if you can't find it on the periodic table, it might be a polyatomic ion, so go there and have a look before you spend another 5 minutes looking for it. So ammonium chloride would be a good example of that. Ammonium, if you recall, is the only possible polyatomic cation that we have on our chart. But if you don't remember that, you might be spending some time looking through all the metals on your periodic table, looking for ammonium. You've spent 5 minutes, you still don't see it. Good way to remember, oh, it might be on my chart of common ions. So You flip to that and then you'll see it quite quickly on the left hand side. So ammonium has the formula NH4 plus. And chloride, there's two places you can look up your anions. One is just in your chart, and you could look up chloride here because it also gives simple ions. So chloride is actually listed in your charts, just Cl minus, but you might also just recognize that that IDE ending is a little hint. It's a nonmetal. The last letters have been changed, and so this is actually referring to Cl minus chlorine, which has become a chloride ion when it gained an electron. So we've got Cl negative 1 is the symbol for it, for a chloride ion. And the next step in writing the formula is to bring down those charges, or swap and drop. So this is a positive 1, so I bring down the 1. This is a negative 1, I bring down the 1. Remember, we don't include 1s in our formulas, so we simply write this as NH4Cl. And there's my answer. Let's do another one. Ammonium hydroxide. Well, we just looked up ammonium, so that saves us some time. Hydroxide, again, you might spend a little bit of time on your periodic table looking up something that looks like hydroxide. It is not hydrogen. Okay, hydride would be the way you would see hydrogen written if it was in a compound, okay, as the second element. But this is not hydride, this is hydroxide. And so when we don't see it on a periodic table, that's a hint to come over here, and we will find hydroxide right here. It is OH minus. Hydroxide is one that you might recognize from Science 10 because it is found in bases. Okay, so hydroxide, there we are, and OH minus. And we're going to go ahead and swap and drop, bring down the charges. So again, my 1 comes down, your 1 comes down over here. We don't write 1s in our final answer, so we simply have NH4OH. Let's do another example. Aluminum nitrite. Aluminum, I could look it up on here, okay, and it is shown. There's a simple ion, aluminum 3+. That's a metal. Or you could look it up on your periodic table looking for a metal. Aluminum is found there. Okay, it's right here, and it has a 3+ charge. And nitrite, as soon as you see that ending that's not IDE, there's a really quick hint that this is a polyatomic ion. So I go straight to my polyatomic ion chart and I look up nitrite, being very careful not to look up nitrate, and NO2 minus is nitrite ion. There's the formula, and now I'm going to swap and drop my charges. I'm going to bring down this 3, and I'm going to bring down this 1, and now I'm going to clean it up a bit. So I have aluminum, only one of them, so I don't need to write anything there, and I have nitrite, NO2, and I have 3 of them, so I need to put brackets around the nitrite and put my 3 outside the brackets. I do that because I have 3 nitrite ions, and in order to indicate that there are 3 ends and there are really 6 oxygens, I need to put the brackets around it and put the subscript 3 outside. That refers to everything in the brackets. Okay, if I didn't do that, notice that if I were to write NO2 3, and I forgot to put the brackets around it, that formula actually means that there is 1 aluminum, 1 nitrogen, and 23 oxygens, which is definitely not the correct compound. So anytime you have more than 1 polyatomic ion, you must put brackets around it when you're writing the formula. All right, go ahead and give some practice problems a try, making sure to use your chart and look up your answers in the back of your Hebden textbook to make sure that you are doing them correctly. And the more you practice, the easier these become. Good luck.